Okay, and after that we have something called use. What do you mean by use? Wherever you are making use of a value of a particular variable, the point, okay, that point refers to use. Okay? And together I call it as DU pair, where D stands for definition and U stands for use. After that, we have gone through definition, use, clear path, DU clear path. Okay, in the directed dependency graph, okay, wherever we are dealing with flow of data, okay, we have two terminologies, definition and use. If you have defined a variable at a particular node and the path from the node where you have defined the value up to the point or the node where you have used or made use of that particular value without having any intermediate node wherein you are redefining the value for a particular variable, then there exists a DU clear path. Okay, that what I call it as a DU clear path, and in that case I call it as it forms DU pair, definition use pair. Okay. Suppose if you have an intermediate node wherein you are redefining the value, then that node is killing the previous value of a specific variable. Then we have gone through the dominators, post and predominators, and immediate dominators. After that, we have gone through data flow analysis with arrays and pointers, then inter-procedural analysis. Suppose you have more than two procedures in your program, then how do you do the analysis part of these procedures? Okay, and we have seen context sensitivity and context insensitive analysis. What do you mean by context sensitivity analysis? Wherein if a particular procedure is being called by another procedure, then it clearly differentiates which procedure is being called by whom. Okay, that but analysis I refer it as context sensitive analysis. Whereas context insensitive, there is no clear differentiation between the calls made by procedures within the code. After that, we have something called a taint model in web programming. Okay, how we can apply taint mode analysis, that is data flow analysis, how it can be applied in order to know or in order to detect faults with respect to the taints or the programming. Okay, that we have studied. Okay, those are all the things which have been covered in the previous discussion. Today we will be focusing on the features of data flow testing and infeasibility problem. Okay. So let me just begin with the objectives with respect to this particular concept, data flow testing. Okay. Basically, via this unit, we are going to understand why data flow criteria have been designed and used. For what reason we are supposed to use this data flow testing. Okay. What are the important features with respect to data flow testing? Okay, and we are going to study about all DU pairs and all DU paths criteria and all definitions criteria. These three things are very important. Okay. All DU pairs, all DU paths and all DF criteria we are going to study under this unit. And we are going to understand what do you mean by infeasibility problem and how it will impact data flow testing. Okay, then we are going to look into the practical usage of data flow testing. These all are the things which we will be studying under this heading. After that, okay, let me just show you about the next part, why we are supposed to study this particular data flow testing. Okay, if you have seen the control flow graph, the nodes and the edges, okay, just by mere study of nodes and edges in the dependency graph, we will not have thorough testing. Okay, all the test cases cannot be covered if I just look into the nodes and edges. Okay, for that reason, we have to go for the flow of data. Okay, and we are supposed to look into the path-based criteria, which are the paths which are being covered in a particular code, and how many test cases will cover the paths within the code. Okay, and we also will look into the paths which are being uncovered by the test cases. If any path is being uncovered, that means it is infeasible because you don't have any test case which will check for that particular path in the code. Okay. After that, okay, we have one assumption, whereas if a value is computed in one statement and if it is used in another, okay, you will get to know about a bad value computation only when a particular variable value is being used. Suppose if you have declared a variable and if you have not made use of a particular variable, then you will never get to know about the bad value computation. The computation which involves the usage of the value will not be known to you until and unless you make use of that value of a variable. Okay? And that can be analyzed with the help of data flow analysis. Okay, let me come to this diagram, data flow concept. What exactly they are telling over here? Okay, if you come over here, okay, this particular diagram, I'm referring to this diagram now. Okay, you have so many nodes, 6 nodes are there. In that, the important nodes which are under consideration are node number 1, node number 4, and node number 6. Okay, and here value of a particular variable x is defined at node number 1 and it is redefined at node number 4. I hope everybody is understanding. Wherever assignment operator you are using, that will tell you about definition of a particular variable, and now I am considering the variable x. Okay, the important nodes which are under consideration are node number 1, node number 4 and node number 6. Okay, value of x at 6 could be computed, okay, either by making use of a value of a variable x which is being defined at 1 or which was redefined at node 4. Why is it so? Because I have a if condition. If it is true, then it will come over here and it will make use of this variable. If it is false, suppose this, if I consider it as a false, if suppose this condition is evaluated to false value, this is true branch of this if statement and this is false branch of this particular if statement. And if you observe at node number 6, I am making use of value of variable x. But will you be able to differentiate which value is being used? Yes, I can differentiate only when based on the value which will be computed at this particular node, that is node number 2. Okay, bad computation at 1 or 4 could be revealed only if it is used at node number 6. Okay, that is whatever computation is happening with respect to s, and if there are faults with respect to the computation of the value of x can be revealed only if it is used at node number 6. Okay, and this the pair, that is node 1 comma 6 and 4 comma 6 will form definition use pair. In short, I call it as DU pair. Okay, because see, if I consider node number 1, if particular if condition is getting evaluated to true, then directly I will be traversing this path to reach 6, node number 6. In between, I don't have any node which is redefining the value for x. That's why 1 and 6 are forming DU pair, that is definition use pair with respect to the variable x. Similarly, the nodes 4, 6 are also forming DU pair. How is it so? Because if particular condition is getting evaluated to false, I am arriving at node number 4. After that, here at node number 5, I don't have any statement where I am redefining the value for x. Directly I am using the value of x at node number 6 without having any node which redefines the value for x. That's why 4 and 6 are forming DU pair, wherein 4 defines the value for x and 6 will make use of the value which was earlier defined at node number 4. There is no any intermediate node which is stealing the value of the x which was defined at 4, because here there is no statement at all. That's why 4 and 6 are also forming the DU pair, definition use pair. Okay, and you should be very clear with this particular concept, definition and use. Okay. One simple thing that you have to remember is that you shouldn't have any node in between which kills the previously defined value of any particular variable. Then only a DU pair can be formed. Otherwise, no. Otherwise, no. If there are no nodes which will kill, then only you will form a DU pair. Otherwise, not at all. In between, if I have any x is equal to some statement is there, then 4 and 6 will never form a DU pair. That is one important concept with respect to data flow. Okay. After that, I have something important terminologies involved in data flow testing. What is that? That is DU pair. Okay, let us redefine the definition for DU pair. Okay, a pair consisting of definition and use for some variable such that at least one DU path is existing from definition to use. In such scenario, there is a formation of DU pair. Okay, x, suppose if I consider a variable x, okay, in this particular example, okay, previous example itself, okay, here, x, you are defining the value at x, and if you traverse this particular path, okay, there exists a path from node number 1 up to 6. Node number 1, how the traversal is happening? Node number 1 to 2, based on the evaluated expression value, if it is evaluated to true, then from 2 I am traversing it to node 3. Is there any definition which is redefining, reassigning the value for x? No. From 3, 3 to 5, 5 to 6. At node number 5 also, I am not at all redefining the value for x. And at node number 6, I am using the value of variable x which was earlier defined at node number 1. There exists one path from node number 1 to 6. That's why node 1 and node 6 are forming DU pair. That's how you can come to the conclusion that if there exists at least one path, if there exists at least one DU path between the definition and the use, then it will form a DU pair. That is the definition. After that, I have one more terminology called DU path. That is, we have already studied this. Definition, clear path on control flow graph. From definition to use of a specific variable which is under study. Okay. When do you say that it is a definition clear? If you don't have any intermediate node which is killing the value which was being earlier defined, then I can say that as a definition clear path. That is, value is not replaced on the path. If you observe here, definition clear path is very, very important. You have to know about this. Okay, if the value is not being replaced on the path, then I can say it as definition clear. Okay, and sometimes it so happens that if there are presence of any loops within your code, then it may create infinite DU paths between definition and use. Whenever there is a loop, n number of loops are present within your code, then there are chances of having infinite DU paths between definition and use of a specific variable. Okay, these terms are very important and you have to know in order to understand data flow testing. Okay, what do you mean by DU pair? What do you mean by DU path? What do you mean by definition clear path? These things you have to know. Is there any doubts with respect to this? If there is any doubt, please put in the chat box. I will look into that. After that, we have a simple example which will tell you about definition clear path. Okay, let me consider the flow graph, control flow graph over here. Okay, Here, if you check out, okay, you have basically 6 nodes, okay, and the nodes which are under focus are node number 1, 4, and 6. Let us redefine definition clear path with the help of this particular diagram. Okay. At node number 1, I'm defining the value of x, and at node number 4 also, I'm defining it. At node number 6, I'm using the value of a variable x. Okay. As per the definition clear path, okay, which is the path that is forming definition clear path. One simple example for definition clear path is from node number 1, 1, 2, 3, 5, 6. It is forming definition clear path. Why? Because there is no any intermediate node which is killing the previous or which is replacing the previous value of x. That's why node number 1, node number 2, node number 3, node number 5, node number 6 will form definition clear path. Because x is not reassigned any value between the node number 1 to 6. Whereas, okay, if you consider the other way, that is from node number 1 to 4, 5, 6, are they forming definition clear path? Not at all. Why is it so? Because at node number 1, I have an initial value which is being assigned for x, whereas I'm killing the previous value of x by replacing it with a new value at node number 4. That's why it is not the particular example for definition clear path. So this is not forming definition clear path, whereas these nodes from 1, 2, 3, 5, 6 will form a definition clear path. Because here you are killing the previous value of x at node number 4. Node number 1, you have already defined it, which is being replaced at node number 4. That's why the nodes 1, 2, 4, 5, 6 are not forming definition clear path. Okay, but 1 comma 6 over here, okay, it is a DU pair. Why? Because if you come over here, okay, 1 to 6, 1, 2, 3, 5, 6, because of the existence of this particular nodes, okay, why 1 and 6 are forming DU pair? Because if you traverse through this particular path, that is from 1, you will move on to 2, then 3, 5, and 6. Is there any node which is replacing the value of x in between 1, 2, 3, 5, 6? No, that's why 1 and 6 are forming DU pair. Because there is the existence of DU, that is definition clear path between 1, 2, 3, 5, 6. That's why I'm taking the first node and I'm taking the last node which are forming DU pair. Okay, with the help of definition clear path, you can come to the conclusion about the formation of DU pair. I hope everybody is understanding this particular concept. Okay, after that, I have something called adequacy criteria, which is most important part in testing. If you go for any testing, okay, so basically structure-based testing, that is what I call it as a white box testing. Okay? White box testing basically deals with what? The program structure. You focus on the structure of the code in order to test the program. Instead of going for functionality, you go through the structure of the code in order to find out the loopholes with respect to your code. Okay, whenever you deal with structural things, okay, you have one important terminology, that is adequacy criteria, okay, with respect to testing. What do you mean by adequacy criteria whenever I'm dealing with data flow testing? Okay, these three things should be satisfied with respect to data flow testing. These three things are to be satisfied, and these things will form adequacy criteria. It is minimum requirement in order to carry out data flow testing in order to discover faults based on the flow of data with respect to your code. Okay, let me consider the first criteria, that is all DU pairs. What do you mean by DU? Definition, use pair. All DU pairs criteria basically states that each DU pair should be exercised by at least one test case. Okay, this criteria, what it states, okay, in the code or in the program, you have n number of DU pairs. It's not that you are going to have only one DU pair in a code, single code. No, you are going to come across many DU pairs within the program. Okay, and as per the all DU pair criteria statement, each DU pair, okay, should be exercised by at least one test case. What do you mean by that? You are going to test all DU pairs by executing against at least one test case. You should have one test case for single or individual DU pair. That is the criteria, adequacy criteria. That is all DU pair criteria. Okay. But what is the advantage here? The advantage here is that if you have a test case which is being designed for each of the DU pair, then you are testing them individually. By doing so, you will get to know about the faults within your code very easily. Okay, that is one of the adequacy criteria. Okay. After that, I have something called all DU parts. Okay. What do you mean by all DU parts? It is similar to all DU pairs. Okay. And basically it deals with non-looping paths. There are no iterations as such. Okay. Whenever you have a DU path, you know now. By this time, you know already what do you mean by definition use path. Okay, each simple DU path should be exercised or should be traversed by at least one test case. Okay, in testing, the primarily you are going to write the test cases and you are going to group them together to form a test script, and you are going to run the test script in order to test the software. Okay, so n number of test cases will be designed whenever you test a software. Okay, and there should be presence of one test case which is going to traverse each path. Okay, for single path you are going to have one or more test cases which will look into or which will traverse a particular path in the code. That is all DU path criteria. Okay, then we have something called all definitions criteria. What do you mean by that? Definition, you already know definition and use. Okay. For each of the definition within your program, there should be at least one test case which is going to exercise DU pair which contains that particular definition which is under consideration. That is what I call it as a all definitions criteria, which in turn tells that whatever value is being defined at a particular node will be used somewhere. It is not left unused. Okay, it has to be used somewhere. Okay. These three criteria are basically used in data flow testing, and I refer these three criteria as adequacy criteria with respect to data flow testing. That is all DU pair, all DU parts, and all definitions. Okay, so this is about the adequacy criteria associated with data flow testing. After that, there are certain difficulties which are involved with respect to data flow testing. Okay, suppose I have an array x of I. This is basically we are explaining with respect to the loop. Okay, xi is equal to xj. When this will happen whenever I equal to j, then only this I can consider. Xi is equal to xj. It is possible only when I equal to j, then only they will form DU pair, otherwise no. But will you get to know about when this I will become equal to j? If it is a big, huge code, then it's very hard to know when it will form a DU pair, definition use pair. Okay, and whenever you are dealing with the pointers also, arrays and pointers, it is very hard to carry out data flow testing with respect to these two structures, that is arrays and pointers also. Okay, that is what we call it as a problem of aliases. Okay, if they are same, then you get to know about when they are going to be the same. Okay, suppose in this case xi is equal to xj only whenever the value of I will become equal to j. Okay, so these are certain complexities involved in data flow testing, basically with respect to arrays and pointers. Okay, after that we have something called the data flow coverage with complex structures. Again, complex structures here refers to arrays and pointers. Okay, so whenever we come across arrays and pointers testing, by applying data flow analysis, it is very, very critical. You cannot perform so easily on arrays and pointers because sometimes we are going to have aliases for arrays and pointers and we don't know at which point they are going to form a DU pair. Okay, and sometimes it becomes infeasible to test particular cases scenario with respect to arrays and pointers, which will give rise to infeasibility, which we'll be looking into later stage. That particular concept will be studied in the later step. Okay, for example, and they also tell that if you carry out data flow analysis on arrays and pointers, it is little bit expensive. Okay, it is little bit expensive because if you go for pointers, okay, you always deal with the dynamic memory allocation, okay, and pointer arithmetic, okay. Uh, these all things will contribute to infeasibility. Infeasibility. What do you mean by infeasibility? We'll look into it just after a few minutes. Okay, dynamic storage and pointer arithmetic, they make the analysis infeasible. You cannot have any test case which is going to test these particular scenario associated with pointers and arrays. Okay, so let us just know, okay, one point you have to keep in mind with respect to complex structures is dealing with arrays and pointers and applying data flow analysis on them is quite complex because of these things involve dynamic memory allocation, pointer arithmetic. They make the whole analysis infeasible and it is quite expensive as well. Okay, let us just try to know about infeasibility problem. Okay, they have taken the same example over here, but only few things have changed. Okay, here there are 6 nodes, but only few nodes I am considering over here. That is node number 1, 3, 5, and 6. Suppose the condition which is being defined at node number 1 and node number 5. If there is no change at all with respect to the conditions which I have written at node number 1 and 5, that is first is equal to second condition, then 3 and 5, they are not feasible DU pair. 3 and 5, they are not feasible DU pair. Okay, see, one point you have to remember with respect to infeasibility, simple, okay? Don't worry if you don't understand this particular diagram. Because what do you mean by infeasible? What do you mean by the term infeasible? Which is not realistic, which is not realizable one. Okay, I call it as infeasible. Okay, so with respect to testing, which scenario you call it as infeasible? Suppose a particular sequence of actions cannot be realized or tested with respect to your code, then I call it as infeasible problem. That same thing they are explaining with the help of this data flow testing. Okay, suppose a particular DU pair, if you are not able to trace that particular DU pair via designing a test case, then I call it as an infeasibility problem, because no test case can cover particular DU pair definition use pair. Are you all getting? Let me explain with this diagram itself. Suppose you have a condition which is always, suppose I have written if x, and I have defined, let me take simple example to explain the infeasibility. Suppose at this particular node 5, I have written something called if x, and at node number 4, x is equal to 4. Suppose I have written like this. Okay. Here I have something called x is equal to 4, and here the condition is if x. What do you mean by this particular statement if x? That is whenever x is having a positive value. Since x is equal to 4, 4 is always positive term, whatever, it will never be a false statement. It is always gets evaluated to true value, and this traversal will happen 5 to 6. But 5 to 7, will it happen? Never. You cannot traverse 5 and 7, cannot be traversed at all. Okay, so you will never have a test case which will test for the traversal of nodes from 5 to 7. That is infeasible path. Okay, you have to understand like this. What do you mean by infeasibility? Wherever there is a scenario wherein particular nodes or particular DU pair cannot be traversed via designing a test case, I can say it as a infeasibility or infeasibility problem. Okay, that is with respect to the data flow analysis and infeasibility. Okay, so they have just explained you with the help of path. Okay, whenever path-oriented nature of data flow analysis is taken into consideration, okay, certain combinations you cannot traverse. Okay, it is impossible to distinguish between feasible and infeasible paths. Okay, if you have n number of more paths within your data flow graph or control flow graph, then you have to do more manual work to test those paths within your code. And in practical scenario, it is highly impossible to cover all the paths, to write all the test cases that will cover all the paths. So coverage cannot be achieved if there are more number of paths in the control flow graph. Okay, and from the analysis, it is stated that number of paths is exponential in worst case. It is never be linear, but okay, almost in the worst case scenario, number of paths will increase exponentially. Okay, and all DU paths. What do you mean by all DU paths? You have already studied under the heading the adequacy criteria. All DU paths. There is going to be one test case which will be checking the DU path. Individual DU path will have at least one test case which can be tested for which can be used for testing a particular DU path. Okay, that in practical, okay, in real world scenario, if you are testing with the help of this data flow analysis, then all DU path is more often impractical. You cannot have a test case wherein each test case is designed for each DU path. Okay, that means, in other words, a DU path, okay, will never be tested. Okay, will never be tested by designing a single test case for each one of them. Okay, there will be certain issues or there will be certain scenario wherein for a particular DU path you will not be having any test case for testing purpose. That is infeasible DU paths. Okay, that is about infeasibility. Okay, these are the things you have to know with respect to data flow testing. Okay, so in this particular section, you have to know about the DU pairs and about the infeasibility problem and the problems involved in testing arrays and pointers, which are referred as complex structures, that is aliases, and about infeasible paths as well. Okay, these things have been covered under this section.